Have you ever held a piece of gold, a ring, a coin, or just a simple shining flake? It feels heavy, doesn't it? It feels ancient. For all of human history, this metal has captivated us. It's driven explorers across oceans and inspired artists to create works of breathtaking beauty. We have built empires on its promise and honestly fought wars for its possession. Gold is woven into the very fabric of our civilizations, a symbol of power, a symbol of wealth, a symbol of love, and a symbol of the divine. It gleams from the crowns of pharaohs and the domes of sacred temples. It's the prize at the end of the race and the treasure buried on a pirate's map. But what if I told you that the story of that gold, the story of every single atom in that ring on your finger, didn't begin here on Earth? Its journey is way grander, far more violent, and honestly, infinitely more wondrous than any tale of pirates or kings. To find its true birthplace, we have to leave our world behind. To make gold, you need an oven of unimaginable power. The furnaces here on Earth, even the very core of our planet, are just not hot enough, not dense enough. The universe reserves the creation of its heaviest treasures for its most violent moments. For a long time we thought the answer was supernovas. Imagine a star, many times more massive than our own sun. For millions of years it burns brightly, fusing lighter elements into heavier ones in its core, hydrogen into helium, helium into carbon, and so on. But eventually it runs out of fuel. The star's core collapses under its own immense gravity, and then rebounds in a cataclysmic explosion, a supernova. This explosion is, honestly, one of the most luminous events in the cosmos. For a brief time, a single dying star can outshine its entire galaxy. In this inferno, for just a few moments, the conditions are right to forge many of the elements on the periodic table. The intense heat and pressure slam atomic nuclei together, creating elements like iron, silver, and, we once thought, all of the gold. A supernova scatters these newly minted elements across space, seeding the next generation of stars and planets. The gold was made, forged in the heart of a kilonova, a cloud of freshly minted atoms blasted into space. The journey had just begun. Think of these atoms as cosmic seeds cast upon the great dark ocean of space. For millions, even billions of years, this cloud drifted through the void. It traveled through the vast cold emptiness between the stars, a lonely voyage across staggering distances, silent and dark for eons. Over immense timescales, this debris began to mix with other clouds of gas and dust. It joined a vast swirling nebula, the cosmic nursery. Our solar system began as a gigantic spinning disk of gas and dust, about 4.6 billion years ago. This primordial cloud contained hydrogen, helium, carbon, oxygen, iron, gold, all forged in previous generations of stars and their explosive deaths. The gold in your jewelry was once part of that cloud. Gravity is the great sculptor. At the disk center, matter collapsed inward. Pressure and temperature soared until fusion ignited. A star was born, our sun. Farther out, clumps formed, dust grains, pebbles, rocks, boulders, planetesimals. So the gold arrived, delivered by asteroids to the surface of a young Earth. It wasn't just sitting there in shiny piles, it was scattered, diffused throughout the planet's crust. To become the concentrated veins we mine today, it needed water, and of course time. Lots of time. Over geological ages, water heated by the Earth's inner warmth circulated through cracks and fissures deep within the rock. This superheated water acted as a powerful solvent, dissolving tiny, trace amounts of gold and other minerals from the surrounding rock as it moved. It was a slow, patient process of chemical collection. This hot, mineral-rich fluid, known as hydrothermal fluid, would then travel upward toward cooler regions of the crust. As the water cooled, it could no longer hold the dissolved minerals in solution. The gold began to precipitate out, solidifying along the walls of the fractures. Over millions of years, this process repeated again and again, depositing layer upon layer of gold. This is how the famous quartz veins, laced with brilliant yellow metal, were formed. Prospectors know to look for these veins, which are essentially the fossilized plumbing systems of ancient underground hot springs. But not all gold stays locked deep underground. The relentless forces of erosion, wind rain ice, are constantly at work, wearing down mountains and exposing these golden veins to the surface. Humans have always tried to explain the wonder of gold. Without the tools of science, we created myths. These stories are beautiful in their own way, attempts by our ancestors to make sense of this magical substance. Many ancient cultures like the Egyptians saw a direct connection between gold and the sun. The sun was a powerful god, Ra, and gold was thought to be his flesh fallen to earth. Its eternal, unchanging gleam was a reflection of the sun's own immortality. This is why pharaohs were buried in golden masks and sarcophagi, to associate them with the divine and ensure their own eternal life. In another corner of the world, the Inca of South America had a different, though equally poetic explanation. They called gold the tears of the sun, and its counterpart silver, the tears of the moon. For them, gold was not a currency to be hoarded but a sacred material used for religious rituals and to adorn their temples. When the Spanish conquistadors arrived, they saw only monetary wealth. The clash between these two worldviews, gold as sacred offering versus gold as economic power, led to tragedy. The Inca myth reveals a deep reverence for the natural world, linking the heavens to the earth through this shining metal. Another persistent myth is that of the alchemist. For centuries, brilliant minds, and some not-so-brilliant ones, were obsessed with the idea of transmutation. They believed it was possible to turn common base metals like lead into precious gold. They mixed strange concoctions, chanted incantations. So why is gold so valuable? It isn't just its beauty or the myths we've wrapped around it. Its value comes from its cosmic rarity and its unique physical properties. As we've seen, the universe doesn't make gold easily. You need the most extreme, violent, and infrequent events, the collision of neutron stars, to forge it. Then it has to travel across the cosmos, get caught in the right cloud of gas, be incorporated into a forming planet, and be delivered to the crust by asteroids. The sheer improbability of this chain makes gold exceptionally rare compared to elements like iron and silicon. This rarity makes it a stable store of value, one of the best conductors of electricity, and it never corrodes. There is a tiny amount of star-forged gold in your smartphone, your computer, and your television. Its utility extends even further. The story of gold is more than the biography of a metal. It is a lesson in perspective. When you hold a piece of gold, you are holding something forged in an event so powerful it shook the universe. You are holding the remnants of dead stars. Proof that the cosmos is dynamic, violent, and creative. Every atom in that gold has traveled for billions of years across trillions of miles to get to you. It connects you to the grand history of the universe. This journey from a kilonova to your hand should fill us with wonder. It reminds us the elements that make our world were made in the hearts of stars and their explosive deaths. We are literally stardust. The universe isn't separate from us. We are part of it, and it is part of us.